Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, Network Controller Security with Dana Yanch and Dan Demers from Elisity. Dana, welcome to the show.
Thanks, Darren. Yeah.
Hey, Dana, tell us a little bit about your background and why we're talking today, and then we'll head over to Dan.
Yeah, absolutely. Thanks, Darren. So I'm Dana Yanch. I'm Director of Technical Marketing at Elisity. My background has been hardcore networking for the last 15 years. A lot of software-defined networking, wide area networking, the SD-WAN world, which is something I was focused on for a long time. And then the cloud world. I went to work for a company called Aviatrix for a period of time. And it's been great, but I came back to my roots here on network security at Elisity.
Great. Thanks, Dana. What about you, Dan? Your background's different than Dana's. I know that. Because we've talked quite a few times.
Yeah, I started, I've been in networking most of the time, but I started out in the services area with advanced services at Cisco for a few years, down in oil, did some oil and gas work down in Houston, and then I moved over into kind of the SASE SD-WAN space after that for several years. And then worked with Dana in the past, and then we jumped over here to Elisity, and now more focused on network security, but also software-defined security. It's kind of an elusive term here in the sense of where it quite lands, but from a micro-segmentation through identity.
Yeah, this is something really unique about what your guys' approach to securing networks and things like that. Very different than what I've seen traditionally and what I learned. Right, when I started doing networking, it's very different and very unique. So I was very fascinated. So let's start off with the first question: Why? Why not just use VLANs and firewalls just to protect my network? Isn't that good enough to create microsegmentation? Because that's what I was told. So yeah. Why do any different than that?
Yeah, it's a pretty common question. We've been doing one thing for a long time, and why fix what's potentially not broken? But actually, it's quite broken in this day and age. So, I mean, for me to talk about that, I need to preface it a little bit about what we've been focused on for the last 15 years or more in network security, and that's been hardening the perimeter of the network. I'm sure you've heard that terminology before, the perimeter of the network. And that's things like the WAN edge, the internet edge, DMZs, remote access edge. And so what we've spent a lot of time and energy spent there making this impenetrable wall around our enterprises. And that's still important, but that problem's been solved for a long time. Firewalls do an incredible job keeping people out of the network. But for the most part, we neglected the inside of the network, where there's been this explosion of new connectivity requirements because of all this IoT and IOMT and OT and IIoT that's just being connected internally to absolutely everything, to the internet, to resources, and yeah. So
it reminds me, we did a podcast on zero trust architectures, and we compared it to a castle. So what you're telling me is you built a really strong moat. You built really strong walls around your castle, and we've done a great job at that. But what you're saying is inside the castle, once I'm inside, it's like a free-for-all. Is that pretty safe to say?
Exactly. For the most part, that's pretty much what we've seen. We've been looking at a lot of networks with our customers and finding out that the inside of the network has been implicitly permitted. Because, if you've made it past this robust outer wall and into the network, you must be a legitimate user.
You must be
device,
yeah, right? Exactly.
But that's really not the case. It's not the case this day. And so, I mean, as you're well aware, the majority of the attacks that are happening these days are happening from the inside of the network, namely from exploited, trusted users' devices and applications.
It's almost like the Trojan horse. Well, that's where Trojan horse came from, right? The whole concept.
Yep.
That's right.
They brought the Trojan horse inside the security walls of Troy, right? That's what happened.
That's right. I mean,
and then they came out and killed everyone, right?
Yeah, I mean, what that means is that these threat actors, they're crawling around the network that's got all these channels that are fully open that we've never sat down and analyzed, and it's shut down, made it so that only what you need to access to do your job is open and everything else is closed off, right? That's something we've totally just ignored. And now it's time to go back and fix this, because all sorts of organizations are being, they're getting brought to their knees because of all the threats that are happening now.
All right. So, but the term I've heard on this is just microsegmentation.
Yeah.
So why not just create a bunch of VLANs with firewalls around each VLAN and say, hey, only these applications can talk to each other, and why not just go that route?
That's right. Yeah, that's a good question, and that's what we need to answer here, and that's what we've been focused on solving for at Elisity. The problem with traditional mechanisms of segmentation, and I say that lightly when we talk about VLANs, but things like leveraging VLANs or IP ACLs or firewalls with access control entries in them, there's all sorts of reasons why they don't work today for lateral movement security. They worked great for the edge of the network, and they worked great for very specific, maybe bottlenecks or aggregation points. I'll talk about three common ones, okay? And that this should frame the conversation pretty well. So, number one, VLANs, ACLs, firewalls, their scalability and operational efficiency is questionable, right? Managing VLANs, IP ACLs, and firewalls across large enterprises is done quite manually, right? It's not a scalable mechanism. It's not a distributed software-defined architecture. It requires box-by-box configuration, line by line. They're not dynamic in any way, and they don't respond to anything happening on the network. They're just not intelligent enough, right? These are kind of dumb mechanisms that kind of work for certain environments, but in the grand scheme of things, for large enterprises, lateral movement, it's not a efficient way to do this. What happens also that we've seen is that you might try to use these features, these functionalities, and you'll come back and realize that there's a network full of random holes. It's like a Swiss cheese network because people have put little access control entries that allow this and that, and out of nowhere you now have
well, that would be me.
Yeah,
that's your software developers, right? They do that all over the place.
Yeah, because we just want the thing to work, right? So like, okay, we're under pressure. Let's just make it work, and nobody comes back and solves for it.
I'm your worst user as far as security goes. Because if I need to download something, or if I need a port open so I can attach to an external service, I open the port.
Yep.
Right? I don't ask permission. So, Dan, you were going to say something about this. How do you manage all this?
Yeah, one of the things that always hit me was that your users are your greatest asset, but also your biggest risk. In the sense of users are, especially the operators of networks, in the sense of, hey, I'm going to open up that VLAN or change this one piece just to do a quick test, but then don't undo the change. Or
because something else happened, right?
Or VLAN started, especially the VLAN example, we've actually seen this in the real world numerous times, where a VLAN or some kind of VRF or a construct will start with a use case, and then it'll slowly creep to other use cases, and all of a sudden what was a 10 device VLAN is now having 40, 50, 60 devices. And in the OT world, it might have 6 or 7 different processes running inside of it, because that was the trusted, the safe VLAN that wasn't the dirty one. But then it kind of blew up over 10 years because these environments often, they're static a lot of the time, but they kind of grow slow and aren't documented.
Yeah.
Okay, so this brings up something interesting. What you're saying is VLANs and firewalls do work in very static environments where I know everything that's going to happen on there, and in small scale.
Well, one thing
that's what I just heard, right?
Yeah, that brings me to the. That's fine. Yeah, that brings me because it got excited because that brings me to the other 2 points around the efficacy of these mechanisms, right? The fact that VLANs and firewalls are inherently in the wrong place in the network to provide lateral movement security is the big problem. I mean, if you're in the same VLAN as another device that or user or application, that communication channel is completely open and available, even though it may not have to be. And firewalls are typically not even deployed in a strategic place where it can handle that access level lateral movement. You have to funnel traffic up to a firewall, get it back down. It's just it's not the most efficient.
And then you have a bottleneck. And,
exactly.
Yeah.
Yeah. So just they're not even seeing the traffic that we're trying to secure most of the time.
Interesting.
Yeah.
Very, very interesting.
Yeah.
So that goes into that scalability issue as well then.
Yeah.
Right? First off, they're not catching the right traffic. Doesn't really prevent lateral movement inside the same network, right?
Yeah, not to mention, if I'm a VLAN and I have a process running inside, it's some kind of use case, what's to stop me from going from port 3 to port 32 in the same VLAN?
Nothing.
There's nothing there.
Yeah,
There's
nothing.
nothing to, and it comes down to what's the intended function that should be occurring versus what could occur. And that's often people will design security around what they'll put security up into a point of, all right, this is what I'm going to allow. I'm thinking it's whitelist, but it's not. They don't actually think of how could this be turned around and used differently, because when bad actors are looking at networks, they're not looking at how they should be functioning. They're looking at how they can take what is functioning and twist it to get some type of outcome they're looking to do. And they're not using your tools, they're using their tools.
Well, isn't that a developer as well?
Oh, sure.
I'm a software developer, right? And I'm trying to find ways to get my work done most effectively. And I will jump ports. I do that, right? Yeah. Which is awful. I know. But I do jump ports, right? Especially if for some reason a port goes down, I'm going to jump ports onto something else and try other through a range of ports. I mean, that's just something that I've done.
Yeah.
But what you're saying is that's kind of dangerous in the current VLAN environment, right? Because I'm kind of open.
Yeah, you're absolutely right. And firewalls, nobody's placing hundreds or thousands of firewalls across their entire access edge to get that type of visibility. It'd be impossible to manage, and it'd be fiscally restrictive, right? There's no way a lot of organizations can handle putting these firewalls everywhere.
So isn't that the balance between flexibility that I need to actually deliver my application or my data, and also security? Aren't they at odds with each other?
Yeah, to an extent. To an extent, they are at odds, and it be based on current technologies. Because for the last 15, 20 years, ever since the firewall, in the 90s really kind of became a thing, it's been the go-to tool. Hey, I need security, I'll throw a firewall in. Hey, I've got to separate two things, I'll throw a firewall in. It's always been this L3, 2 or 3 hops up in the network kind of thinking. And the whole market, all the vendors including, have, the major vendors have kind of gone down that path in the sense of, hey, we're going to invest there because it may not be the best possible way to do it, but it's a way that is rinse and repeatable. And that.
Oh, I see. So they first did it because it was easy.
Exactly. Well, it was probably, day one, first firewall iteration, 80s, 90s-ish, true kind of modern firewall thinking. It was a wild success day one. It's more like day 20,000, many years later. The success, calculation is much different.
Well, and I think a lot of that has to do with the scalability, the sophistication of cyber attacks now.
Yeah, totally.
All right. So what you're telling me is we've got an internal combustion engine, the firewall, and it's time to replace it with electric.
I love that. I'm a massive Tesla fan, so yeah, absolutely.
All right. So what? You have a third one though, right? You gave me 2.
Yeah, the third one to me is probably the most interesting out of them all, and it's the fact that these legacy solutions, these legacy security/segmentation solutions, don't take into consideration identity, or the context, or the behavior of the asset that's connected to the network. So it means it's really unintelligent. It's a really network-centric, topology-dependent, and rigid way to provide some measure of basic security. I mean, an IP address tells me nothing about the legitimacy of the asset and the network that it's attached to, right? It doesn't tell you anything. So how can you secure this network in a dynamic fashion when you don't even really know what's out there connecting to the network? How can you make a policy in the first place with any type of granularity if all you're matching on are 5 tuple network constructs as your policy matching criteria? It doesn't work in this day and age.
Yeah, that's really fascinating, because what you're saying is every device, according to the network, every device is equal.
That's right. Yeah, they all look the same to
right.
us. How are you supposed to get granular?
They all look the same. Right. But can't I analyze traffic and then, based off the type of traffic, I can do different things with it. But that's
where's
not
the analysis happen? It's going to be happening how many hops up? And
several hops up.
Essentially.
Yeah. That's right.
Yeah, which means I have exposure.
Yeah. And let's say we tapped everything and we saw everything. The analysis is going to still happen in the traditional thinking, multiple hops away, firewall thinking, or some kind of appliance. And then any type of enforcement it may or may not be able to do is going to be up there. It's not going to be down here. And so I might know something occur, and that's very valuable. That's not to take away from the value. It's the whole concept of protect, detect, and then kind of some kind of response. That's very to oversimplify it, but we still need the detection. We still need to know something bad happened, even if we didn't protect ourselves. That's incredibly, and that's actually an underused part of cybersecurity in the sense of there's more value to be put in there. But the ability to stop something from happening and then detect something could have happened and I killed it before it happened, that's something that can happen and should be happening at the very edge of the network, as close to the asset as possible, whatever that asset may be.
That's really interesting. Let's go back to my castle. I got my castle. So what you guys are telling me is, as people are coming through my castle, I'm sending my report on who's come through and what they're carrying with them off to another city to go tell them, and they're going to analyze it, and then they'll get back to me on who's in my castle. That's what today happens.
Yeah, and then to keep the analogy going, they'll make a rule somewhere on the road outside the city of, hey, if anyone comes and goes from this city, we're going to kill that that behavior. But the what if, and then it's not even a what if. What happens often is it all stays within that little realm. It doesn't actually leave and go to the other city or hit the highway and so forth.
Yeah, great analogy.
Oh, very, very fascinating. Okay, guys, so we've scared everyone.
There's a solution, don't worry.
To find out about a solution to solve the network controller security problems, listen to Dana and Dan explain identity-based microsegmentation in the second part of this interview. Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.